how much of any nutrient does a plant need? So we're going to now start looking at nutrients, where do they come from, and then how do we see relationships to plant health, its vibrancy, and its nutrient relationships in the soil. If you do your soil chemistry test, so you take your soils to get tested, and I would recommend before you purchase a property, you would want to do a soil test to see what you're actually buying. That would be smart. And then afterwards, periodically, say each year, you can then get a gauge of how your soil fertility management program is working. So here it's pretty simple. This is what we see, and we see the nutrients that they list, and they typically like to list what they call the most prevalent or big nutrients first, the ones that make the most impact or visible impact anyway to our plants, down. And the carbon nitrogen ratio. And then here, if we look at this particular test, which is called an acid digestion or combustion test, which they need basically to do in a laboratory. It's not really something possible on a home level. But nitrogen, in this particular, they were testing the macadamia versus the adequate range, and they had 1.82. And the adequate range that they're recommending is 1.3 to 1.5. What would that be an indication of this type of soil? What did they do to get so much nitrogen? More than likely, they were using non-organic agriculture, so they have more nitrogen. So that's what they're looking for. So we would want to be within the 1.3 to 1.5. If I have less, then you would realize, hey, I need to work into getting more nitrogen in my compost, for instance. How can I do that? Or maybe utilizing compost tea, so we could brew more of the bacteria in order to get them into our soil. So that's what you look for down the list. And a lot of the tests will actually give you recommendations, and we'll see some charts that you can look up on the internet. Very simple to see, where do I find nitrogen? Where do I get potassium? Where do I get these minerals from? What are these? What products could I purchase? So another test is on this particular one, they're looking at how much of a particular mineral was removed from the soil for a particular crop. So if I do corn, and the corn would take out how much of this mineral this year, because I'm exporting the mineral. The mineral comes from the soil into the plant. I sell the plant, well, the mineral has been exported. So how much would I need to do to replace that mineral each year? So this mineral replacement, whether that's through compost or any of our biofertilizers. So here the total calcium that they have, exchangeable and available calcium. And they looked at different plants on their farm, and then we can also see that different plants, fruits, vegetables take up different amounts. So then they would read that. So, but that's just typically the top 10 centimeters. People don't typically dig down very deep, but the plant roots definitely go down deeper than the top 10 centimeters. So it's also recommended that you get like a profile of like the top 10 centimeters. But what about 1 foot down, 2 foot down? Remember, our trees pull the minerals up from depth. So that would be another good indication of what the actual mineral profile would be. So if your roots are not going down deeper, is that through compaction? So how do I alleviate compaction? Maybe compost tea or aeration with a plow. And how far down does the soil go, and what are these nutrient concentrations that we're going to look for? So here we can see a test that they did 3 different depths. So they tested in the same spot, 3 depths, and you could see that the nutrient profile changes with the depth. Okay, so a particular plant with a longer, say, taproot, something that we call like dynamic accumulators, if they were able to go down, they could access from below minerals that may not be present on top. So if we bring those up, we get them into our compost regimes, then we can feed them to the plants with shallower roots, like vegetables. Okay, so this might be something to get like a bush or trees, legume trees especially. If the legume tree comes up, I can harvest the leaf matter to make compost, or chop and drop as we'd see in the food forest, and that's what we can do. So then we come to pH. This is a pH chart, and we want to see where these particular minerals are available in different pH levels. So if the pH of our soil is off, then that you don't really have availability. So that particular mineral is tied to particular pHs. So without biology, without understanding that you can read or we test, you're stuck with pH as your sole arbiter of what is available to the plant roots. So we don't have any other way to monitor. So most farmers, especially at a beginning level or organic agriculture, only really measure pH in their soils. But getting into a larger scale, especially if you're going to be selling things from your property and you're not returning your manure source back to the property, we're going to need to, on a long scale, measure so that we can work on adding the minerals back in. So if we add organisms or we add plant nutrition, it's no longer the rule that we can only use chemistry alone. So we want to try to see this in combination, pH, but also with the test. So what's going on here?